Okay, so welcome everyone. I'm Janet Reyes, the Geospatial Information Librarian here at UCR. Are you able to see my slides right now?
Yes.
Okay, great. Anyway, I am the Geospatial Information Librarian, and I'm offering this workshop on QGIS building skills with vector data as part of our observation of Open Access Week at the library. And to tell you the truth, Open Access Week was last week, but I was gone for most of last week. So we are kind of tacking this on a little bit afterwards. But the reason it's part of the Open Access Week programming is that QGIS is a free open source software for geographic information systems. So it just seemed appropriate to give this kind of workshop at this time. This workshop is being recorded, and the recording should be available to you a few weeks from now, perhaps, on the library's YouTube channel. What else do I need to tell you? I have a co-host today. Her name is Jeanette. She'll be helping me with the waiting room and popping things into the chat and monitoring the chat because I'm presenting from my little laptop and I don't have access to seeing the chat so much as I go along. So with all of that, I think that's all the housekeeping I have. Let's continue on with the UCR Land Acknowledgement. So we at UCR would like to respectfully acknowledge our responsibility to the original and current caretakers of this land, water, and air, the Cahuilla, Tongva, Luiseno, and Serrano peoples, and all of their ancestors and descendants, past, present, and future. Today, this meeting place is home to many Indigenous peoples from all over the world, including UCR faculty, students, and staff, and we're grateful to have the opportunity to live and work on these homelands. You'll see at the bottom of the slide that I have a link to a map of native lands. So that's something, once you get a copy of the slides, you could explore as you wish. And if I didn't mention that before, I do plan to email you all a copy of the slides. So all of the links that you see and all of the material that you see, you'll have access to maybe later this afternoon or probably first thing tomorrow for sure. All right, so here's the workshop overview. We'll have a couple items to think about before you start. We will then look at performing joins, and there's two types of joins that can be done. Both of these deal with adding data to a geographic representation, a map in a GIS. And then the last three bullet points, the Choropleth map, generating Centroids, and making a heat map, those all relate to more of the cartographic aspect of a GIS. So presenting the data in a way that will make sense to the person who is viewing the map. You see at the bottom of the screen, I have a link to where you would go to download QGIS if you have not already done so. I think it's going to be a little tricky to follow along with the workshop pretty much. So I'm hoping that between giving you the slides and you being able to view the video, you would be able to practice it at your own pace. But I hope this demonstration of some basic skills will be helpful to you as you go along using QGIS. So before you start, a couple of things here. If you want to add data to your QGIS session, what you would do, a lot of times what will work is that you can drag and drop the file from the browser panel in QGIS down to your layers list. And that's really simple and clean, and it's great when it works. But there are times when that's not going to work if anything is a little less than straightforward, perhaps. So a way that will always work is what you see at the bottom of the screen here using the data source manager tool. It's just a little bit of an interface where you have to make some choices before you add the data. And this is something that you're always going to want to use if you have, say, a CSV file that has data that you want to create a point layer in a map from. Just dragging the CSV down into the layers list is not going to create a point layer for you. So you do have to go through the data source manager in order to create that point layer. So that's something to keep in mind. And then the other thing is projections. As I was getting ready to prepare this workshop, I kept running into problems with projections, even though I've been at this a while. So it's very easy to do. One way you can avoid trouble with projections, though, is just think about how you want to deal with maps that are in different projections, or maybe there's a data layer that you create that doesn't have a projection, but you need to get that in sync with the other things that you've got going on in your project. So what you can do is go at the very top of QGIS along the top menu tab. There's a tab for settings. You go to choose options, and then from the window that appears, you choose the CRS tab, which appears at left, and then you can make choices like which default projection do I want to use for my project. The one that is the default in general is, you see WGS 84, which is a global projection, and that's fine if your data is global, but you may not want that one if your project is always going to be very localized, like to Southern California or Italy or something like that. You don't need a global projection that averages out a lot of the imperfections throughout the world. So, you would want to get a little more specific perhaps on which projection you pick. Same thing, you can make choices for the layers, like what am I going to do if a new layer comes in? Which projection would I want it in? What do I want the QGIS to do with it? So anyway, you have some ability to avoid trouble with projections by going here first and setting up your choices. Okay, so let's talk about performing joins first. Like I said, these will get you the ability to add data to your existing map that it doesn't have at the present time. And we'll talk about table joins first. So when do you want to use a table join? Well, it's when you've got attributes in a table or a spreadsheet and you want to add them to your spatial data. So a use case, today is an election day in some parts of the country. So I think this is an appropriate use case perhaps. Maybe in a few days, there will be tabular election results by county for a state, say Virginia, and you have a map of Virginia counties and you would like to add those election results to the map. Well, you don't have to go through and do it manually. A table join will help you get that data into your map pretty quickly. So when you're going to do a table join, the table that you're drawing the data from and the attribute table for the map, they must each contain a column, or what sometimes is referred to as a field, that contains the very same spatial identifier. It could be a census tract, it could be a city, what's called a FIPS code, county, whatever it is, it has to be the same in those two columns on the two tables. And furthermore, the data within that column has to be expressed identically for the match to work. So that means one table, if it has states, it might have the state spelled out like California. In the other table, it might be, I'm distracted here, let's see. It might be, CA, so you want to have that consistent. And abbreviations consistent, whether it's an integer or a string, especially when we're using some of these codes. All of that is important that there's a match. If you're using latitude and longitude, there must be one column for each. That's the way it's going to be in the GIS and your source data. Sometimes those come with one column that has latitude and longitude in it, both. You'll have to do some data cleaning perhaps and create separate columns for those before you're able to do a table join. Note, however, that the column headings themselves, what the column is called, that heading does not have to be identical in the two tables. So you don't have to change that. You just have to make sure the data is kind of a good match from one to the next. Okay, so what I have done is create a couple of, actually 3 videos altogether, demonstrating some of these techniques. And what I am going to do is stop talking and set this up. So hopefully you will be able to see the video and hear the video as I play it. So give me a second here and we will see if we can get this to work. For this demonstration of how to do a table join, the scenario we have here is I'm going to add happiness scores of countries of the world from a table to a map of countries of the world. And as you can see, I've already added my two layers by dragging them down here from my browser. But let me take a look at the attribute tables before we proceed. I'm right-clicking now on this first layer to open the attribute table. So this is the happiness scores, and you can see I have a column called country, and then the scores themselves, and then if you scan over here, there's all kinds of interesting possible correlative data about different other types of things that you could really get into and explore. But for now, I'm just interested in the rank itself and the score. I'll close this, and now I want to show you the attribute table for the world countries data that I found. So we have a column called country, and you would think, well, that's the column that I want to match with the other data set. But as we can see, some of these things that are called countries are really islands that belong to another country or a parent country. So I'm thinking what I want to use as my matching column is this country AF, or probably affiliation is what that stands for, when I go ahead to do the table join. So let me close that, and you can notice that there's 249 records in this table, whereas the happiness data only had 155. So there's a mismatch there, either because of the islands, and I know for some countries they just weren't able to get data. So there's all those kind of things that you might encounter as you're searching for data as well, and have to figure out how to deal with them. Okay, so to do the join, what I did was open the processing toolbox, which a couple different ways you can do it. You can click on processing and then choose toolbox. I scrolled down to vector general, opened that up, and I found join attributes by field value. So I'm double clicking that to open the interface. So the input layer, that's the thing that you want to have changed as a result of doing this procedure. And it was picking from among the layers that it saw, and yes, I do want the world countries polygon layer to be modified as a result of this. Now I have to identify the table field, the column, that I want to use as the matching feature. So for this one, remember I talked about country F would be the better one of the two choices, so I'm going to do that. And then my input layer is not going to be the same data set, it's going to be the happiness data, and I need to pick which table field I wanted from that to match the first one, and yeah, country would do it. So now I get to pick which columns from the second data field, which do I want to add to the attribute table of my map. And like I said, I'm going to go after happiness rank and happiness score just for now. You could do just one, you could do all of these columns, it doesn't matter. It's just up to you. So we've got that. I'm going to check the box for discard records that can't be joined. For join type, I think I want to do one to many just to cover the bases of any possibilities there. It's going to create a temporary layer. I'm going to click run. I'll close this. You can see I now have something called joined layer. And if I right click on that and open the attribute table, if all went well, at the very back end now I've got two columns that now show the happiness rank and the score. Let me just also show you quickly the other way to go about joining a table. If I right click on world countries and click on properties, I get this big menu that shows up. You notice one of the choices is joins. If I go down here and click on this plus sign, it says add new join, and this window pops up, and I can pick from among the layers I have and set it up and so forth. But this one will change your initial layer. It won't create one of those temporary layers. So you have to be pretty confident that you know what you're doing when you do this, because it will modify directly your initial file. Okay, so hopefully that came through. I apologize for all the bumbling leading up to that, but that's a pretty powerful tool. And this slide kind of summarizes the process that we went through. We found the join attributes by field value in the processing toolbox. Here's the interface that was used. I provided links to the data that was, that was used in the demonstration. And then here is a slide that talks about the second manner of doing a table join, which, it's a little bit more direct, but you lose your initial table. So like your geographic attribute table is altered and you don't have the original. So you have to be pretty careful that you know what you're doing, because you're not going to be able to walk back to the previous table very easily, at least. And that's the interface for that second way of doing a table join. Okay.
Real quick.
Sure.
Real quick, there was a suggestion.
Yes.
If you can make the videos full screen for the next few videos.
Yes, I will try to do that. I'm sorry. When I get flustered, sometimes my brain freezes. So I will try to do that. Thank you. Okay, so for a spatial join, when would you want to use that? It would be when you have attributes on one layer that you want to add to a different layer based on their spatial relationship. So for instance, if you had crime data, like points representing a crime that occurred over, in a city, say, and you have polygons that represent neighborhoods of the city, you would be able to tag the points that represent each crime with what neighborhood it's in. And I see there's a raised hand. I'll stop talking and listen.
Yes, I'm sorry. I don't see slides. I see only screenshot of the video. Could you please share another screen? I'm not sure if it's only mine problem, but yeah.
Yeah. Yeah, let me, is that better?
Yes, thank you.
Okay, I'm just all goofy today. I'm so sorry. Yeah, so you'd want to use a spatial join when you want to associate maybe neighborhoods with the crime that occurred, or if you wanted to have a summary of the number of crimes that occurred in each neighborhood. And a third way of doing a spatial join is something like nearest. So when do you have, maybe you have a points of recreation centers and you would want to associate them with the closest mass transit line for each recreation center. So those are some examples of spatial join. And so guess what? I have another video and I think this time I'm going to do better. So fingers crossed. Let me just pause and think this through and we'll get there, I'm pretty sure. To demonstrate spatial joins, I've selected some data from around the city of San Diego. One layer I have is a shapefile that shows city council districts. And I also have a CSV that I extracted from a much larger database of requests for fixing potholes in the streets around the city of San Diego and adjoining areas. So let's see how we can get data from one of those data sets to the other and vice versa. I'll start by bringing in the shapefile that has the district, council district boundaries. I'll just drag it down here from my browser, and there we can see it represented. The same is not going to work for the CSV though, because we want to see them as points, and right now just dragging the CSV layer down will not do that. What we need to do instead is navigate up here to the Open Data Source Manager. And what I need to do is try to find that CSV file, which I just happen to have right here. I'll go ahead and open. And I will make sure everything looks good here. What we need to do is make sure these X and Y fields are populated. So I happen to know that the X field should be populated with longitude, or LNG as it's abbreviated in this table. and the Y field should be latitude. And I'll just go ahead and add those and close. And now you can see we have points on top of the polygons. I'm going to go ahead and save this as a shapefile also, because this is just a representation and we can't really do much just with that. So just need to take a quick tour up here to, I right clicked and then went to export. I'm going to save features as, and let me pick the name potholes underscore 0621. And let's just go OK with that. Now this gives us a file that looks exactly the same as what we just had, but now we can do things with it. So I'm just going to remove the old one. Okay, now we have things we can work with. Let's go ahead by starting with adding something from the polygon layer to the points. So in other words, some data that's nested right now on the attribute table of the polygon file, we can transfer over to the points. And let me just open this up so we can see what that looks like. I'm right clicking and I'm picking open attribute table. So here are all the attributes for the districts. And I'm going to pick the jurisdiction name here. I think that might be a useful thing to add to the attribute table of the points. So what we want to do is go over to our processing toolbox here and we find join attributes by location. I'm double clicking that and this comes up. And it takes a good guess on what we think we want for the base layer and the join layer. So you always want to think about the first layer that you want to have represented is the one that you want to have changed, something added to it based on the second layer. So in this case, we are adding something to the point layer. So I'm going to pick that one instead. I will leave the join layer as the district data because that's what we want. We're going to leave the geometry as intersects. So in other words, any point that sits within a particular district is going to inherit its particular feature from the attribute table. And I don't like this interface very much, but what we need to do is to pick which field, or maybe you can pick more than one field. But you come over here to this ellipse and it lists all the column headers that we see in the district data. I'm going to pick the jurisdiction name and click OK. And see this interface, it doesn't show you what you picked, it just says that you picked one thing. I think that could be better, but anyway, I'm not the one designing this. I want a one-to-many join. I'm going to say discard records which could not be joined. If I wanted to give the resulting field in my points table a prefix to just distinguish it somehow, you could go ahead and do that here. For now, I'm going to create a temporary layer, and with all of this done, I am going to click Run, and I will close that. And now you see we have what's called Join Layer. If I right-click on that and open the attribute table, if all has gone well, as I go over, at the very end, there is now a column of jurisdiction name which was not there before. So that was inherited from whichever polygon the point was sitting in. So that's how join attributes by location works. Now, what I want to do is kind of the reverse. So I'm picturing each council district member might want to know how many pothole requests came in for the month of June in their district. And for that, we can use a slightly different tool called the Join Attributes by Location parentheses summary. And that's sitting right underneath the first one that we used here in this list of tools. We can just click on this, double click on it. Again, we have to be smart about which layer do I want in the first box, and the one that I want is the one that's going to change. So in this case, we're adding it to the polygons of districts. I'm going to change that. And I want to go back to my original potholes for the join layer. Intersects again works well for me. Which fields do I want to summarize? This can be a bit tricky depending on what your data is like. I'm going to pick what's called the service name because that's consistent all the way through this particular database as pothole, and it's just what I want is a count of the number of orders or requests in each district. So that works well in this particular case. I'll go OK. But then the second choice here is summaries to calculate. And you can see where this could get really tricky depending on what your data is, but also very useful. You can do all kinds of things, like if you have numerical values associated with what you're interested in, it can calculate that, all kinds of things. In my case, all I want is count. So I'm just going to click that and OK. And again, I'll say, just for the sake of it, I'll discard the records that could not be joined. And I will click Run. You can see now I have a joined layer as a polygon. I'm going to close. And not all the districts, of course, have pothole requests in them. So we're only seeing the joined layer where there was an existing pothole request. And if I right-click and open the attribute table of this temporary file, at the very end, you see this service underscore NA underscore count. That tells me how many points fell in each of these council districts. So that gives you an idea of how these two tools work. The third option is join attributes by nearest. This would be something like if you wanted to associate a point with the nearest road or something like that, or stream. That would be a tool you could use for that. But I think these two are the ones that you're most likely to encounter in your search for data. Okay, so I hope that came through all right, and you saw how we can use the spatial join tools to associate data with a different layer based on their relationship to each other. So these next slides just kind of run through that, what we saw on the video. And it doesn't have to be points and polygons. It could be lines and polygons. It could be points on lines. You know, it's whatever geometry you're dealing with in your vector data will be fine. So now here's a resource slide where I've given you a few other places you can look if you want more reinforcement on how to do these. So yeah, for table joins, I have two up here, and you'll see this a lot in this presentation. QGIS has some tutorials that they provide from their website. So of course, those are always really good. And then I've also found some other either blogs or YouTube videos or guides from other libraries and things that also kind of go over this material. So you might pick up some other tips that I didn't cover or cover very well from these other sources. So especially I want to point out this one at the bottom, the spatial joins using the join attributes by nearest tool. So that's something I mentioned but didn't really go over, but this is something where you could learn how to do that one if that's of interest to you. All right, I'll pause just for a second to see if there's any questions on that before we go on to some of the more cartographic aspects of this workshop. Okay. A Choropleth map. So this is a map that's shaded. It has polygons that are shaded different colors based on some attribute that they have. And you would want to make this when you want to represent the relative amounts of something occurring in defined areas. And it's important, and it's so important that I've got this on the next slide too, that when you're making a Choropleth map, you want to use normalized data, such as percentages or rates or something like that, not representing raw amounts. That's misleading cartography. So just remember that. So some use cases where you might want to make a Choropleth map, it might be a % of the population that has a particular health condition, and you want to represent that by county. Or you might want to show which states have the highest per capita income, something like that. And the shading or how dark the color is will kind of convey how much of something is going on in that defined area. So again, don't use raw amounts to represent data when you're making a Choropleth map. You will want to verify your data field type is numerical, not string. I ran into this when I was preparing this workshop, so heads up on that one. But there is a way to fix that without going back to your original data. And it's just something within QGIS called the refactor fields tool. It helps you establish a numerical value rather than a string, which is like characters value. And then there's some things you have to choose wisely. One is the classification method. So how are you going to break your data into different classes? And there's, if you're familiar with statistics, there's, several options there. You want to think about the number of classes that you want on your map. And the third thing is which color ramp you're going to pick to represent the different types of data. Now I'm taking a look at the clock, and because of all my bumbling early on, I'm going to skip the demonstration video on this one. However, you will have a link to the video when you get the slides a little bit later on, so you'll still have a chance to see it. But pretty much the slide goes over the way you set this up. What you would do is right-click on the layer in your list of layers, choose Properties, and then go to Symbology. When you get to the Symbology interface, you change the very top drop down from single symbol to graduated. Then you'll see a value option, and that's where you select the field that contains the data that you want represented. You get to pick an appropriate color ramp. They have many choices. And then you set the mode, and the mode is how you're breaking up your data into different chunks. Is it equal interval? Is it, janks and natural breaks? You get to pick which way you want the data to appear. And if you want, the default number of classes in QGIS is 5, but if you want to have, 7 or maybe 3 or some other number in there, you can set that as you see circled at the bottom there on the left-hand side. And then you just click apply or okay. Now in the demonstration that I have, I was using that happiness score value to show the countries of the world that have different happiness ranks. And on this next slide, you see part of the result. And you can also see that some of the countries didn't participate. So that was a problem. And that's a problem you're going to run into. Your data may not be complete for everything you want to have. But in this example, the darker the color, the happier the country ranked in this annual happiness score. So anyway, you get the basic idea. Again, I have some resources here for you. Basic advice for Choropleth maps. It's not just about QGIS. It's just in general when you're making one of these maps. Here are some things to think about. I've covered a lot of them, but there's probably more in this article. The color choices, the color brewer is really good to make sure you select a set of colors that will work, say, for instance, with people who are colorblind. So they can interpret the map just as well as somebody who can see colors. Again, there's documentation available in QGIS, and I found 2 tutorial videos, one from Michigan State University and one from this fellow in Indiana who went through the process of creating Choropleth maps with different sets of data. Okay, generate centroids. This is pretty straightforward, so we don't really need a live demonstration and we don't need a video for this one. But the concept here is you generate a point that's representing the polygons that you have. And you do this when you want to maybe generate a symbol that can represent some attribute of each polygon. Or you can provide the user with a different thing to click on to view some data associated with the polygon. So use cases. Maybe you want to create symbols of varying size, and the size of the point symbol relates to the proportion of vaccinated adults, say, in the county or the census tract or whatever it is. Also, you can use the Centroids as a way to create pop-ups, maybe for data on obesity, whereas the polygons, it might be a Choropleth map that is conveying data on median income. So it's a way for you to split related data and kind of represent two forms of data at the same time, so that you're getting more information across to the people looking at the map based on the symbology. So those are some reasons why you might want to generate a Centroid. The Centroid tool is pretty easy to find. You can either go up to the very top of the QGIS menu, click on Vector, choose Geometry Tools, and Centroids is the very first one that appears there. Or you can go to the Processing Toolbox, which would be that little symbol there. When you open up the Vector Geometry choices, and you'll find Centroids under there. And that's the interface. It's pretty simple. You just have to pick your input layer, and that's pretty much it. So the way the QGIS Centroids tool works is my understanding is it takes the mathematical average of all the, I think it's the points along the perimeter of the shape, and takes the average. And that's great when you have chunky, blocky, circular sort of polygons. Where it doesn't work so well is if you have oddly shaped polygons, like ones that are really snaky or curvy, or concentric polygons, like picture something like a donut. You know, where's the centroid for that donut? It's going to be in the hole, which is not part of that polygon, right? So a way around this, if you really want to have a point sitting inside the polygon itself and guarantee that you have a point inside the polygon, is to go to one of the plugins that's been created for QGIS, and this one's called RealCentroids. And it's pretty easy. You just go up to the plugins tab at the very top. You go to manage and install plugins, search for RealCentroids. Once you've added it to your QGIS interface, this is the icon that will appear in your toolbar, and you just click on that and you get this little interface, and off you go. So I believe my next slide, yes, has kind of the difference between the results of the two. So the one on the left is the one I created just using the Centroids tool that comes in QGIS by default. And I was so lucky, I picked UCR parking lots, and I just picked a subsample of them. And lo and behold, this curvy one was a perfect illustration of a time when the Centroid is falling outside the polygon. With the RealCentroids tool, I went ahead and created that. And now you see this point is sitting inside the polygon like we would want it to, right, for most of our purposes. And you can see that sometimes, you know, it turns out the same. It's a direct overprint of the original Centroid. And sometimes it's a little bit off, and sometimes it's positioned quite differently. So anyway, those are some things to know if you want to generate Centroids. And here are some resources. I love this illustration, talking about the donut holes or the concentric polygons. You can see at the top, you've got like 3 Centroids in the smallest polygon, and that's not exactly what we would have wanted. So the RealCentroid illustration at the bottom kind of shows you what that tool can do to make it kind of work better for your cartography. Yeah, and here's this second resource I have over here is interesting because it talks about weighted Centroids. So not just taking the kind of in middle of the polygon, as it were, but if you have attributes within the polygon distributed, like population or light pollution. You've seen those maps of places at night where the light is really bright over cities and things. So you can do all kinds of really interesting things to move that centroid towards something that's meaningful in terms of what's distributed within that polygon. So hopefully that makes sense. So you have some options there in addition to just kind of a straight geometric centroid. All right, this is the last item I'm going to show you today. It's about how to make a heat map. And you want to make a heat map? Well, when do you want to do that? If you want to visualize dense point data. You've probably all seen maps where there's lots of points and they're kind of overprinted, and you have no idea until you zoom in whether what you're seeing at a smaller scale is like, that's how the points are, or oh, if I zoom in, there's going to be even more points, you know, underneath these points that I was seeing. You can show the relative difference in importance of occurrences. So I'll talk about that a little bit in the use cases down below. And also it's a way to avoid accurate depiction of sensitive data. So I'm thinking of something maybe like archaeological sites, where you want to show that there are a lot of archaeological sites in an area, but you don't want the public to see exactly where they're located. So this will just keep, the heat map will give you an idea of where it's dense and where it isn't, but not necessarily revealing the exact location of things. So use cases. If we were looking at a city with traffic accidents, you just might want to know which parts of the city have the highest number of traffic accidents. But the second example there is getting more to that relative difference in importance of occurrences. So you might have, again, crime data that's represented by points, and you might be interested not only in which areas have lots of crime, but which areas have the serious crimes going on. So in other words, if two areas both have, say, 87 crimes in a time period, and one is mostly some of the more less serious crimes, and the other one has a bunch of murders and things going on, you might want your heat map to reflect the severity of what's going on in addition to the quantity. So you can make a heat map like that. And you have some heat map options in QGIS. There's the easiest and most straightforward one is using the heat map renderer, and I will give you a quick demonstration of how that works. If you wanted something that's really something to preserve longer, and maybe if the darkness values you wanted to have quantified and that was important to you, what you could do is turn the heat map into a raster that you could save, and it would have a legend associated with it. And then if you wanted to generate a time series of heat maps, there's a plugin called Batch Heat Maps where you could do that. Okay, so I am going to try to give you a live demo. We'll see if this works. I know we're getting close to the end here. Aha. Okay, so what I did here is I found some data on the location of Chipotles in the United States. And I was surprised to see how many Chipotles are in the East Coast of the United States. But again, when you're zoomed out this far, it's really hard to tell, well, is it really any more dense over here than it is in Southern California and so forth? So what you could do is create a heat map from this. And it's really pretty simple, especially the rendering type. So what I'm going to do is click on the layer over here. And then I'm going to click this little symbol all the way to the left, right above it, which is the layer styling panel. That opens this up. I'm going to change the single symbol here to heat map. And that's pretty ugly. I'm not sure why they use gray as a default, because almost nobody wants a heat map that is gray or shades of gray. But luckily you can change the color ramp to reds, which is something that's more relatable. And that's good. You know, we have a little bit of a problem here still, right? One thing I want to point out is you can pick what radius from the point the color extends and starts to taper off. And, you know, this could be important if you have something like, say, well, how far will people drive to a Chipotle, and make that, you know, the basis of your radius. Or if you have a predator sightings and you know what their range, territorial range is, you might want to, you know, correlate the radius that you choose to that kind of thing. So it can be important. What we want to do here, though, to make this a map that kind of makes some sense, is just change the opacity here. So I'm going to use the slider and kind of bring it down to about 50%. And now we can see. And honestly, it looks like the Northeast does have a higher concentration or a bigger concentration of Chipotles than Southern California does. So anyway, that's the basic idea, real simple. And you can also do almost the same thing by going, let's see, by right-clicking, going to properties, choosing the symbology, and like you see here, Heatmap is one of the choices there as well. So the default would be single symbol, but I was playing with this before, and it's almost the same interface, just some minor differences there. So you've got some choices there. Okay, if you wanted to make a raster heat map, I made a couple slides on this because I spent a lot of time trying to figure this out. I'm not sure how many of you are interested in it, but you would need to make sure your data is in a projected coordinate system. If it isn't, then you have to go ahead and reproject it. Then use that reprojected layer for the next step, which is using this heat map parentheses kernel density estimation tool. And you do some settings. It takes several minutes to process. And yeah, the result is something like that. I got this one to work. I will, however, show you my first attempt, and it was horrible. So that was frustrating after waiting it to process for 20 minutes to get that. So yes, QGIS and GIS in general, a lot of times it's a matter of trial and error and finding out what step that you misfired on and what you can do to fix it. So it's all a big learning process. So here are some resources regarding heat maps. Again, we have a QGIS tutorial. This video from GeoDelta Labs, I really like it. It's really paced nicely and it's very clear presentation. So if you ever see GIS videos created by GeoDelta Labs, I would recommend them. I think they're very well done. If you wanted more information about how to create that raster heat map, this would be a good resource to look at. And I like this one on the bottom because it has a good explanation of what you would go through on trial and error for picking your radius and also your pixel size if you're creating one of the raster heat maps. So that's it. We made it. I am, again, so very sorry that I had that bungling at the beginning, getting the videos to work, but hopefully no great harm done. I will stop sharing my screen now and see if you have any questions. Also, if it's not already in the chat, I hope it's going to get there soon. But we have a survey for you guys to complete. Let us know if this is the kind of material that you're looking for, if it was helpful, what other kinds of workshops would you like to see, so forth and so on. So just taking a minute to do that survey would help us a lot do better to serve you. Good. Thank you so much.